Hello guys, welcome to Apex Mathematics. My name is Bino. In this video, we go through the following question, which is based on quadratic number pattern. 2.1, we are given the quadratic sequence with 2 as the first term and 3 as the second, 10 as the third term, and 23 as the fourth term. And 2.1.1, we write down the next term of the sequence. For our first differences, we have 3 minus 2, which is equals to 1. And we also have 10 minus 3, which is equals to 7. And we also have 23 minus 10, which is equals to 13. We have to determine term number 5. And for now, term number 5 minus term number 4 will be denoted by the letter X. We have to determine the second differences, and the 7 minus 1 is equals to 6, and the 13 minus 7 is also equals to 6. So the x minus 13 we expect to be equals to 6. To determine x, we can realize that the 7 plus the 6 is equals to the 13. So we expect that the 13 plus the 6 will give us the value of x. So 13 plus 6 will be equals to 19. And we also realize that the 2 plus the 1 gives us the 3. And the 23 plus the 19 should give us term number 5. 23 plus 19 is equals to 42. So term number 5 is equals to 42. We move on. Question 2.1.2, we determine the nth term of the sequence. So the general term, we have Tn is equals to a multiplied by n squared plus bn plus c, and we know that 2a is equals to the second difference. So 2a will be equals to the second difference is equals to the 6. From here we solve for a by dividing both sides of the equation by 2, and our a will be equals to, so that 2 and that 2 will cancel out, and 6 divided by 2 is equals to 3. So the a is equals to 3. We have 3a plus b is equals to the first term of the first difference, where we determine that a is equals to 3. So in the place of the a, we substitute 3 plus b is equals to the first term of the first difference is equals to 1. So 3 multiplied by 3 is equals to 9 plus b is equals to 1. We move the 9 from the left to the right, it will change sign to negative 9, and our b will be equals to 1 minus 9, which is equals to negative 8. For the quadratic number pattern, we have a plus b plus c is equals to the first term of the pattern, and our a we determine that is equals to 3, and our b is equals to negative 8 plus c is equals to the first term, and the first term is equals to 2. 3 plus minus 8 will be equals to negative 5 plus c is equals to 2. Moving the c to the right, it will change sign to positive 5, and the numerical value of c will be equals to 2 plus 5, which is equals to 7. We substitute into this formula. We end up with Tn is equals to 3 multiplied by n squared minus 8 multiplied by n plus 7 in the place of the c, and this will be our nth term. Question 2.1.3, we calculate the 20th term of the sequence. Term number 20, n in the place of the 20. We have 3 into 20 squared minus 8 multiplied by 20 plus 7. So term number 20 will be equals to 1047. Question 2.2, we are given the arithmetic sequence with 35 as the first term, 28 as the second, 21 as the third, and we calculate which term of the sequence will have a value of negative 140. Tn in this case is equals to negative 140, and we are to determine n. So the n is the unknown, and we have Tn is equals to a plus n minus 1 multiplied by d for an arithmetic series or sequence where the a is the first term, T1, which is equals to 35, and the d is equals to the common difference. So term number 2 minus term number 1, and term number 2 is equals to 28, and term number 1 is equals to 35. Our common difference d will be equals to 28 minus 35, which is equals to negative 7. So Tn will be equals to 35 in the place of the a plus n minus 1 multiplied by the common difference, which is negative 7. So we have Tn is equals to 35. We distribute the negative 7, and negative 7 multiplied by n will be equals to negative 7n, and negative 7 multiplied by negative 1 will be equals to positive 7. Our Tn will be equals to, so the 35 plus the 7 will be equals to 42 minus 7n. So now we determine the n. So in the place of the Tn, we are going to substitute negative 140. Negative 140 in the place of the Tn will be equals to 42 minus 7n. We take the positive 42 to the left. It will change sign to negative 42. And the left hand side will be equals to negative 7n. Negative 140 minus 42 is equals to negative 182. We solve for n by dividing both sides of the equation by negative 7. And the negative 7 divided by negative 7 is equals to 1. Our n will be equals to negative 182 divided by negative 7, which is equals to positive 26. So it's term number 26, which will be equals to negative 140. Question 2.3. Question 2.3. For which value of n will the sum of the first n terms of the arithmetic sequence in question 2.2 be equal to the nth term of the quadratic sequence in question 2.1? This one is straightforward. We just have to equate the sum of the first n terms of the arithmetic with the nth term of the quadratic sequence. Since we already have the nth term of the quadratic sequence, let's determine the sum of the first n terms of the arithmetic sequence. So the sum to n terms will be equals to n divided by 2 into 2 multiplied by a plus n minus 1 multiplied by d. So we have the sum to n terms, which will be equals to n divided by 2. And for the arithmetic series, we had the first term a, which was equals to 35. So we have 2 into 35 plus n minus 1 multiplied by the common difference, which is equals to negative 7. Our Sn will be equals to n divided by 2 into 2 multiplied by 35 is equals to 70. We distribute the negative 7, so we have negative 7n, and negative multiplied by negative is positive, so we have positive 7. Our Sn will be equals to n divided by 2 into the 70 plus 7 is equal to 77 minus 7 multiplied by n. So we have to determine n when the sum to n terms is equal to the nth term of the quadratic sequence. So we are going to equate the two. So the quadratic, we determine it to be equal to 3n squared minus 8n plus 7. We have to determine what n will be when Sn is equals to Tn. So what will be the value of the n when these are equal? So we just equate and solve for n. So we have n divided by 2 into 77 minus 7n. We equate this to Tn, which is equals to 3n squared minus 8n plus 7. We distribute the n over 2 inside the parentheses, and we have n divided by 2 multiplied by 77, and the n multiplied by the n will be n squared, and we still have the 7 divided by 2, and this is equal to the right hand side 3n squared minus 8n plus 7. We take the items on the left to the right, so 0 will be equals to 3n squared, which we group with the positive 7n squared. So the 7n squared divided by 2 will change sign to positive. And on the right hand side we had negative 8n, which we will group with negative 77 multiplied by n divided by 2, and on the right hand side we had the positive 7. 0 will be equals to 3n squared plus 7 over 2n squared is equals to 13 divided by 2n squared negative 8n minus 77 divided by 2 is equals to negative 93 divided 93n divided by 2, and we have the positive 7. So let's remove the 2 in the denominator. We multiply by 2 to remove the 2 in the denominator, and what we do on the right hand side we also do on the left. 2 multiplied by 0 is equals to 0, and we remove the 2 in the denominator, so we have 13 n squared minus 93 n, but the 2 will multiply with the 7 to give us 14. From here, to solve for n, we can either use the quadratic formula or we can just factorize. So we have 0 is equals to the factors of the 13n squared will be 13n and n, and the factors of the 14 will be 7 multiplied by 2 is equal to 14, and 14 multiplied by 1 is also equal to 14. So let's test first the set of factors. So we have the 7 here, and a 2 there. Okay, this one is not going to work, so let's flip and have the 7 and the 2 there. So this one is going to work, but we must have both the negatives inside the parentheses. So 13 multiplied by n minus 2 will be equals to 0, or n minus 7 will be equals to 0. We have 13n is equals to 2. Solving for n, we divide both sides of the equation by 13. 13 divided by 13 is equals to 1, so our n will be equals to 2 divided by 13. In fraction form, 2 divided by 13 is equals to 0, 153. And remember that n has to be greater or equals to 1. So we are not going to tolerate this fraction. On the other side, n will be equals to 7. Remember that n has to be an element of positive whole numbers. So n has to be greater than 1. Since this n is not, we will consider it to be inadmissible. The correct value of n will be equals to 7. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like and share the channel if you find this content useful.